Hello. Okay, that's working. How was everyone's week? All right. Is it like that? Um, no. I just want this thing to go away. Whatever. Okay, we're almost there. Oh, it takes 30 minutes just to get this freaking set up. Okay, today we're going to talk about sequences. We'll also talk, maybe we'll start learning about Python. I think we will. Seeing as we've got 5.5 hours to go, so we should be able to cover that. If we can do that quickly, then we might even have some time to talk about your assignments. So cool. So sequences and series and patterns, it's all quite critical to what we do. Like architecture is quite repetitive. One of the big reasons why I set assignment 1 to be a stair is because it is a series of steps. It's a series of geometries. It requires parametric series control. Yeah, let's midway through this, we'll get OBS recording rather than Zoom. So we will start by usually when I teach this, I am trying to teach people how to do finger joints for laser cutting. Have you guys all have used the digital labs by now, right? Cool. And you've used the laser cutters? Cool. Have you guys used techniques like this to put boxes together? I saw like an acrylic thing upstairs, like discarded somewhere, but like using this type of finger jointing technique to put a box together? No? Okay. Well, we can use Grasshopper to help us produce these types of laser cutting files. And in doing so, I can talk about series and patterns with this. So even though this has very little relevance to what you're doing, it will teach us the fundamentals. And on top of that, the cool thing is then you've now got a script that makes like a finger joint box. So if you ever need to make a box in the future, you can use that and it'll guide the pieces together and it's easier to glue and all of that type of stuff. So So let's do that. It's not going to do it to like a super advanced level, but it'll be the start of a good box. Ooh, okay, finish that. Okay, so last week we drew some points in space, right, like this. And for every point that we had is for a tree, we had for every tree that we wanted, we had to draw a point. We can get Grasshopper to generate points for us, and in the most regular way possible, we can get Grasshopper to generate numbers for us. We did that last week with the random number generator, but if we want them to be a little bit more regular, there are other number generation systems. The two main ones that I will use are called series and range. So here we've got under set in sequence, we've got series, and we've got range. Series will take a starting number, a step value, and a count, and produce a list of numbers for you. And what range does is it takes a domain. Hang on, it takes a domain. And like a number of steps that you want within that domain, and those number of steps are the domain steps, not necessarily the numbers. So I'll just put 10 in here for now, and you'll see what I mean. And it'll give you the numbers ranging, like stepping from that minimum of the domain to the maximum of the domain. Does that make sense? Yep. Yours looks different to mine?
Is it a different domain?
Huh?
Like this one?
Oh, no. Okay. So that DOM, hang on. Do I have this on, maybe I have this on nicknames? Construct domain. There you go. You can get it there. Is this space better? This is a better space than upstairs, right, for this? Yeah, cool. I'm not using Zoom. I'm not going to use Zoom. I'm gonna transfer it to OBS in a second. If you're having a hard time seeing, there's like either it's probably because you're the furthest away. There's a computer behind you. The screen's up there, or there's a computer down here. Because I understand I've got Zoom up, but the only reason I'm using Zoom is because I didn't have OBS installed. Is that, or just let me know and I'll zoom in. What is it that you can't see? Is it this text? Okay, hang on. Let's do this. Is that better? Okay, cool. That works. Cool. I do not need to worry about that anymore. Okay. So we've got two systems that are generating numbers, right? I'm telling this one to produce 10 numbers, right? How many numbers are we getting on the right? We're getting 10? Yeah? Okay, so just to start us off on like the little change of the brain, type of like rewiring our brain a bit, this value on the left of a panel, I don't know why it's doing that. Stop moving around. Okay, this value on the left of the panel is the index of the item in the panel, right? So we've got index 0, index 1, all through to index 9. So if you look at that last number, that is going to tell you exactly how many items there are in that list, apart from the fact that it's not going to be a number that makes sense to you initially. There aren't 9 items in that list, there are 10, right? Because what number do we start with indexes? 0, right? So 0, when we count with computers or anything like that, the first isn't 1 ST, it's 0 ST. The 0th index is the first one. So anytime we go to get the first item from anything, it's going to be 0. And it kind of makes sense. Like in Australia, what floor is the first floor? The ground floor, right? So ground floor, even though we use the symbol G, is kind of saying 0, right? Because then the floor above that, floor 1, floor 2, floor 3, floor 4, that makes sense, yeah? And as we go down, we get basement 1, basement 2, which is the equivalent of -1, -2, and so on and so forth, right? So the first item being 0 makes sense within the levels of a building, and the levels of a building need to kind of follow that same structure as the way the computer wants to work. I know there are other countries like America who say their first floor, they call it the first floor, which is correct, first floor, but they write 1, right? So I wish the way we spoke and the way we wrote in English, that first was actually 0 ST rather than 1 ST, because then it would make so much more sense, but it's not. So index 0 is first, and we're getting 10 items because it's whatever this value is plus 1. So how many items am I getting in this list? Exactly, 11, right? So this is producing 1 more value than what I put in, because what it's doing is it's producing 10 steps, which is the in-between. So 1, 2, 3, 4, 5, 6, 7. Oh no, hang on. What am I talking about? It divides it up into 10, if I remember. Yeah, so it's producing 11 numbers. There are 10 jumps in between those 11 numbers, right? So if I want my range to function similarly to series, we can modify it a little bit. So we can go into these inputs. If you right-click them, you can put expressions on them. Whatever the value is that's going in is going to be using x as a variable. So what we can do is we can say, I want x minus 1 to be the value that goes into that range. And that now gives me a number between 0 and 10 with 10 divisions in between, which is going to give me this funky value, right? So if I just change that to 11, not 11, sorry. Sorry, I'm just on my internet's definitely having a hard time. Come on, you can do it. Did I say, yeah, that should be right. We want 2. There we go. X minus 1. I'll put a little panel there so that you can see it. So anything that takes a number or a string or anything like that, you can right-click that and set an expression and modify the number. We could also just do an x minus 1 in a component here, but I'm just showing that you can actually just modify the way a number comes into a component. Cool? Okay. If I use these numbers now to make points, so if I grab a construct point, I can use these numbers in that point to construct the x, y, z coordinates. So in this case, I'll go to front view, and that's producing a diagonal line. Right? So we've got 10 points, and each point is going to be a construction of these numbers that are being produced by either the series or that range, right? So 2, 2, 3, 3, 4, 4. If I change my panel over here to start from 5, then I've effectively moved my points. If I change the step distance for the series and make it go up by 5 each time, then I change my line. Let's just stick with this. Let's make a stair first. Then we'll do the finger joint. Can you guys see a stair emerging? Yeah. It's coming, right? Okay. Now, I'm of the opinion that the best way to learn is to make a mistake. So let's make a mistake. And some of you might have even made this mistake. If you're screwing around with this, what do we see? What have I done? I'll do it again so that everyone can watch. I'm going to change this value. What can we observe from what I've just done? Anybody? Yeah, but so I've changed the number of numbers in the range, so it's only producing 5 numbers, right? So what happens when I produce 5 numbers? Exactly, right? So I've got 10 numbers coming out of the series, right? So there is going to produce 10 points. And then if I've only got 5 numbers coming out of the second range, when this construct point component is running, it has there is a different length of list that it's trying to interact with. Yeah. So by default, Grasshopper will take the last item of the shortest list and repeat it. Usually I go to this. I don't have Photoshop on this, do I? No. Okay. We'll use Paint. Why isn't it drawing anything? Ah, okay. Strange. Okay, that makes sense. Okay, cool. So in Grasshopper, we really want to we are relying on its capability of working with lots of information. Is that the air conditioner? Jeez, that's loud. Lots of information. So you can get it to do lots of things. Like the benefit last week was we could draw lots of points and it could do that tree process to all those points and randomly move them. Like it's a time saver, right? So that you've got time saving capabilities and then you've also got like complexity capabilities. So right now we'll just focus on this time saving one because you need it to do the complexity later. We need Grasshopper to be able to understand multiple objects, but we need to understand how it interprets those things. So if I have a list, 2 lists of varying length, then Grasshopper is going to process them. That's not what I want. I want this. Thank you. Grasshopper is going to iterate through them. So this is item 0, item 0, item 1. So that is going to connect. And then index 2 is going to repeat this one. So it's going to assign this point here as index 2 as like a fake index and connect those up. Okay? This is a diagram that we're going to come back to later when we go to advanced data manipulation. We might do that today, depending on what happens, but I don't want to break your brains. So we'll just stick with this, okay? This does not just apply to points and lines. It applies to everything, right? So if I had a list of letters that I was joining up. Then the resulting output's going to be AB, BC, DC, right? Because it's following that exact same diagram. What I usually find people doing is that they will get to their design, doing their little design in Grasshopper, and they get to a point where it gets a little bit too complicated and they can't work out how the data is relating to each other. So you can always take a step back from your problem and try and recreate it with less information, right? So if I was looking at this stuff and I had 5,000 points in one list and 2,000 points in another, and the jumble mess that I was getting out of Grasshopper was just completely indecipherable, then I can just go do a smaller version of that, limit it to 3 items and 2 items or whatever, see the outcome, and then work out how to solve that problem. Okay? So, how do we get Grasshopper to change the way it works, right? What if we have a short list? Like, what other ways could we interpret 2 list lengths? So I'll just go back to Paint. Like, is this perfect? Is this objectively correct? Are there other ways you could do it? Such as, hang on, I'm going to just do this just to make it a little bit easier. What other ways could we interpret this? Is this going to erase? No. Okay.
So you could stop it creating more points for the first list.
Okay. Yep. That is a great. That is one of the examples. So here we go. So you could get it to just use the shortest list, correct? Cool. So that's one way of doing it. So is there any more? Like, how many ways could you connect those two? There's like heaps. Someone's got to have, there's like so many that there's got to be another suggestion. What's another way? Yeah?
Can you go like 0, 0, 0, 1?
Yeah, 0, 0, 0, 1, yeah.
And then 2, 0, 2, 1.
Yeah, you can. Yep. So that is, what's happening is this is now wrapping, right? So this one is going to be treated as index 2, and this one's going to be treated as index 3. Yeah? So yes, that is another way you can do it. So thinking that same way, what's another way you could do it? Rather than wrapping, you could also
0, 0, 1, 0, 2, 0, 2, 1, 3, 1.
2, 1, 3, 1, like that. That's the default way.
1, 0, 0, 0.
Actually, let me just do this. Let me do one. This might actually help in this case.
Connect the numbers in the same list.
What do you mean?
0, 1 in the list. 0, 1.
Like this? Yeah. We're talking about 2 lists interacting with each other. Let me give you a hint. So, sorry, what's your name? Guy at the back. Eric. So Eric suggested wrapping it, right? You can also flip it or mirror it, right? So once you get to index 1 and then index 2, 3 can go back to 1, if that makes sense. And then if we had a 4, then 4 could go back to 0. Does that, so we're almost thinking about like how we relate with the data like geometrically, right? because this is stepping like 0, 1. Oops, that's not what I meant to write. 4. So as we're stepping along, it's stepping through here. But once it gets to this point, where does it go? We can either keep it there, or wrap back, or step back, or stop this, right? Like I can draw these as a diagram. Cool. So you can see that's happening here, right? This one here, the one where this repeats. This value of 10 is now just repeating for all those points, right? There are some components in here that allow you to modify the way Grasshopper thinks. They're called longest list, shortest list, and cross-reference. We won't do with cross-referencing because they can blow up your computer. But longest list is effectively, it gives you access to those patterns that I talked about. So you've got wrap, which is what Eric suggested. See how that it flips down and it goes back to the first number and it just iterates through. You've got flip, which it's now running down the short list and back up the short list as it gets to each of the extremes of that list. We've also got, rather than repeating the last item, you can get it to repeat the first item. Repeat last is how Grasshopper works by default. I don't even know why that's an option, but it's there. And then Isabel said, hey, just don't repeat, don't use the repeated points. So you've also got shortest list, which will trim the long list, and so it just doesn't produce a list that's got that repeating value. And then within this, you've got either trim at the start, trim at the end, or interpolate. Interpolate it'll pick, let's say I've got, it'll pick points along the shortest list. So you can see here it's picking those points, but because picking points is a discrete thing, it's not going to pick them perfectly if you want it to be a smooth curve. So that's why that's not smooth, right? Cool. So what we'll do is let's just use shortest list. And we'll trim the end. Well, the reason we're putting this here is it's going to stop us from over-producing points, right? So I can put 100 points in here, and we're still only getting 5 points out, because if I had 50 in here, then we get 50 out. We get a nice low gradient curve. Cool. So that, whichever one of these is smallest is going to be the one that gets used as the defining number of points that we'll use. Yeah? I'm seeing squinting. Are we all, this all makes sense? It's all making sense? Cool. Okay. Okay, we talked about translation last week. Not translation, Euclidean movement last week. Do you guys remember the difference between affine and Euclidean movement or transforms? Do you remember me talking about that? Okay. You just don't remember what it is? Huh? Which one doesn't change the object? Good. Okay. So what we want to do is we're going to make some stairs from this. Right now, if I just draw a curve through this, it's a ramp. What do I need to do to make it stairs? Yeah. So what could I do to these points to make them steps? Move them either horizontally or vertically, right? Let's move them vertically. Cool? So I'm gonna let you guys go find the move component. It's pretty easy to find. What does the move component take as an input? Huh? Direction, which is, what's another way of saying direction? Vectors. Okay, cool. So who did high school physics? 3 people. Okay, cool. Okay. I hope this is recording. Yeah, okay. Is it recording? Yeah. No. New. How do you pick, like, what is the point of these, okay, oops. Okay, so vectors. A vector is an object that describes direction. So if I have like a starting point here, it describes direction, but it also describes distance. Okay? And when you see a vector, if I showed you how a vector is actually stored, so in this case, if I go make a Z vector, so you were on the right track, what does that look like? Does that look like something else? I'll give you a hint. Vectors look very much like points, right? They're actually the same thing, right? A point in space with a Cartesian coordinate, x, y, z, is also just a vector that is telling that point, if you start at 0 in space, I want you to move, and I want you to move in this direction, in x, y, z, in that direction, and that with this distance, and the point will move to the exact location that its coordinate would be, right? So vectors and points are interchangeable. And we can use unit z to make a vector that just points directly up, and we can give it a distance by its factor, right? So if you know you need to move something in a particular direction and send it in that way, but you know the direction, but you don't know that direction doesn't understand the distance, you can also control that via the amplitude. So if all I had was 001 and I couldn't control the factor of this, then I can always plug a vector into an amplitude and change its distance via that. Because, like, for example, if I wanted to move something 1 at 45 degrees, 45, the coordinate of that's going to be difficult to work out. I know the angle or the direction I need it to go, and then you can tell it, hey, this is how far you want to move, and then that's how far it will move. But in this case, we can just use the unit Z. Okay, these are going to be wacky stairs. So I'm just going to set that to 1. And now we come to a dilemma. How did we get two inputs to go into one, two outputs to go into one input last week? Yeah, we hold shift, right? So what's going to happen if I do this? What do you think? What do you think is going to happen? I'm going to get lines. I'm going to get stairs. No. What am I going to get? Yeah, cool. So these two lists are the same. They relate to each other. So, but what happens is the data gets concatenated. It gets appended onto itself. So when you have components like this polyline, it is going to look at the order of the points in that list and draw a polyline between those points. So in this case, we can use this component here, point list. This is quite useful when you're trying to debug geometry that's not working very well. And another one that's quite useful is this one, point order. So polyline is going to draw a line between 0 and 1, 1 and 2, and 2 and 3. If I use this merged list component, you can see the way Grasshopper is going to work with that data, right? So it is drawing, because of the polyline, is going to draw a line between 2 and 3, 3 and 4, 4 and 5, that it's going to produce that particular output, right? Now, this is really straightforward because we're drawing a polyline, but if you're doing something else, like you're doing like a iterative addition function, like it's going to do the same thing. It's going to add or subtract the previous number. And so if your list is structured that way, that's what it's going to produce, right? So we don't want to merge those two lists together this way. How do we want to merge those lists together if we want to produce stairs? If we just look at these indexes right now, where do we want the first line in our stair? If we're starting at 0, it needs to go between 0 and 4, right? And then from 4 to... Are you sure? We want the first line to go between 0 and 4, and then 4 and... If I draw a line from 4, where does that need to go?
1?
Right, 1, yeah. Here, right? And then 1 and 5, and then 5 and 2, 2 and 6, right? So what we're doing here is rather than working with two lists and trying to connect them together, we actually want to weave them together, right? So there is a component that does that. And you'll find that in set, and it's called weave. Weave takes a number of lists. It actually takes, if you want, you can give it more lists than just 2. You can weave together multiple lists. It takes 2 lists or number of lists and a pattern that list is going to follow. So in this case, we want our pattern to be 0, 1. Now this component breaks the rules of Grasshopper. Okay, so it's not going to look at it's not going to use the shortest list. Okay, it's going to just use whichever list you want, and it's going to use the longest list. Sorry, but it's not going to repeat this pattern with one repeating over and over and over again. It will actually wrap the pattern. So the pattern in this case is a wrap. So it's going to go 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. So that's useful because usually that's how we want patterns to work. So plugging that pattern in and plugging our lists into the corresponding list with that pattern, we can see here now that point order is following the pattern that we've set, and so therefore we can use that for our polyline to get some stairs. Does that make sense?
How did you wrap the panel up?
Pardon? Oh, this, by default, if you put a new line in a panel, it's going to treat that as a single object. You need to turn off multi-line data on the panel. Sorry, I should have mentioned that. That's something I always forget. So right-click the panel, and it's got turn off or on, turn it off. Oh no, turn on multi-line data. Or turn it off. Whichever. Toggle it. Are people getting stairs? Kind of. Okay, I know. So this is something that you might find that isn't working. If I do this, or maybe this, is that the type of thing that you're getting?
I've just got so many lines. I've got to unplug stuff.
Okay, sure. What I'll do is this. I will leave it open like that. Is everyone who's struggling? Eric's struggling. You're struggling? Yeah, exactly.
Hello.
Hey,
Mine looks like this.
that's great.
Oh, that's good.
That's fine. Yeah, that should be all right.
Is it just that I need?
I'll sort you out in a sec.
Okay.
Okay. There's a reason why it looks like that.
Okay.
Yep. Someone else had their hand up. No, these all look good. Oh. There's nothing in your panel. So you want that to be, see how, we want that to be a pattern that uses these numbers. Yeah, you got to type it in. You don't hit enter again. Yep, now click out. Yep. Yay, stairs. They look like stairs, right? Just slopey stairs. We'll sort that out in a sec. Perfect. Well, your first, yeah, no, that's perfect. It's perfect. We'll sort it out. Look. See my stairs? They're bad stairs, right? They're still stairs. Okay? Hang on, let me put the grasshopper script. Hello. Oh, you just, what's going on here? What's your pattern has an extra value in it. Yeah, what's the extra value? Yeah. No, yeah, that's it. Pardon?
How do I make the number show?
Right now they're just really small. See the size value for the point? You see that point list on the right? This component? See that component? What I've been doing is I'm playing with that number, S. So if you want, if people are having a hard time seeing the point, grab a number slider, just chuck it in the S. Pardon? The size, yep. And then you can see like that number slider is controlling the size of the point, the number. Yep. That's fine. Just like mine, look. Yay. Slippery stairs.
Where do you turn on the numbers?
You can do that with this component. There. I'll be a sec. So assignment 1 done, right?
I'm going the other way.
Ooh.
How come?
It's because your domain for your range
Yes.
is going from a large number to a small number, which is fine. Like,
From a large number. Oh. Wait, did I change that? Oh. Oh.
The interesting thing is, especially with Grasshopper, like you are telling it what you want it to do. So if it's not doing the right thing, it's because you've told it to do the wrong thing. Yeah.
I had one question. So as of now, we get a series of linear and repeated stairs. But as if if I want to change the distance between this, so
We'll get that. We'll get that. You're jumping ahead, but yeah, you're doing the right. Yeah, you're thinking we need a landing, right?
Yeah.
Exactly. Yeah, so we can deal with that in a sec. Huh?
Like wrapping
What?
what we learned in the longest list.
Yeah.
Weave component is like wrapping.
No. Oh, the weave component, when the pattern is wrapping. That's so it's going 0, 1, and then what does it do? It goes back to 0, and then 1, and then back to 0 and 1. So it's wrapping, but it's only wrapping the pattern. Okay? There's only a few components that do that, and that's one of them. So I taught you the status quo, and now you've learnt which ones are breaking it. So pattern's one of them. Yeah, what's up? Yeah. Only if the Rhino file matters. So in this case, it doesn't. There's nothing in the Rhino file, right? The Rhino file is empty, so you don't have to save the Rhino file. But if you've got a Grasshopper file that's referencing the Rhino file, then yeah, you should save both. You need to save both. Yes. Yeah, the only reason we want to use GHX is if you're working on the same script as a team and you want to keep track of what's changing. But I've maybe avoid that. You'll see. Just the good thing is everything you save to GitHub, it will save it. So if you have two clashes, you can at least salvage the stuff that you've done. Because if it clashes and corrupts, there's always the thing that you saved that caused that corruption prior to it causing the corruption. So that's one of the reasons why I've sort of pushed you towards GitHub. And then it also tracks you contributing to your group work. So I can just go and look at you guys, like who's been doing the work, right? So there's that reason. So, And as well, it would be nice, like if you guys have a clash, you guys can try and work it out. And if it doesn't work, just email me. But the point is, try and use GHX during this, but I don't use GHX. I only use it for one reason, and that's when I'm developing my own plugins and I'm saving it to GitHub. That's the only reason I use it, is when I'm using GitHub. Cool? Okay. Yeah.
Mine, it's going diagonally around.
Okay. What can you see it doing? So which one's the first index?
This one.
It's going to be this one, right? No, it's that one, not that one.
This one.
Right. So what do you? This point here, this list of points here.
So I have this. If
That pattern shouldn't look like that. Have a look at mine.
if I multi-line data.
Yeah. No. Turn off multi-line data, and then go into the panel. Double click it, like edit it, and then go 0. Enter 1. Yeah. So Grasshopper doesn't know 0, 1 is a list. It thinks it's the string 0, 1, right? It doesn't interpret it as a list of items. A list of items is new line item, and sometimes you've got to tell the panel, hey, this is a bunch of items rather than one object with new lines on it. Cool? Okay. Yeah.
How do you turn off the numbers again?
They're in this thing called point order. Oh no, point list. You can just hide that,
Hide.
or you can,
Oh, okay.
or you're controlling that with geometry. Okay, so the size should be a number. So I'm using a number slider up here. See that number slider? The numbers.
I see.
Yeah. Yep. Cool. But now that's not previewed, so. Yeah, see how the numbers are big?
Yeah, okay.
Cool. Now they're even bigger.
Does that look right?
Yeah.
Okay.
Yeah, it's just got a really slippery staircase.
Yeah.
Yeah, perfect. Just like mine. Okay. I think we're at a point where everyone's kind of there. Yeah? Okay, what's wrong with my staircase? It's sloped, right? Yeah, it's a stramp, right? Not a staircase. Yeah. So what is it? Why is my staircase sloped? Why is my staircase sloped? Yeah, so what have I done? Just remember what we did. We created a sequence of numbers to create the bottom of each, like the level of each tread, right? And then we've done a riser. And what number have I used for the riser?
You use 5.
5 is the number of points. Which one's the riser again? Like the height of the riser? Come on. 1. Okay, just to be really obvious, it's this one, right? Right, because what I've done is I've set 1 because we're moving the points up 1 unit. And you guys could have a different number in there, but I put 1. Now, after I put 1 in, 1 looked great when I put it in, but after I put it in, I changed the number. So you're on the right track. I changed the number of points that I'm using, and in doing so, that changed the height between the treads. And what I've got is a variable height between treads, but then I've got a fixed number, the number 1, for how high I've moved up the vertical for the riser, right? So in this situation, the treads are placing equally across the board, the back of the tread, but then the riser is not the same number as the distance between the treads. So that's how I'm ending up with this slope. Yeah? Please, am I talking a language that everyone understands? Treads, risers? Yeah, cool. Okay. So we should be using the difference between the treads to change the movement of the riser rather than having a fixed number, right? Cool. So let's do that. So the value for the treads is the Z, right? The height, which is being produced by this range. Assuming that you can have, should we assume that we have stairs that will always have the same riser, or should we assume that we might have a different riser? Like, it's up to you guys. What do you want to do? Should we do both? Okay. So if we want one number that defines our tread height, it's going to be the difference between these two or these two or these two numbers, right? So it's going to, our tread height currently is 2.25. It's the difference between 4.25 and 2, right? I could look at this and type it in, but that would be silly. We should be trying to get the value from the model. So if we change the parameter, then the whole model will just follow suit, right? So this is why this is one of the reasons why I want to teach this stuff, is so we can talk about a lot of these set components. So today we've spoken about series and range. We've talking about weave. We'll very soon talk about the opposite of weave, which is dispatch. But we are now going to use list item. Did we do list item last week? I think we did, but I didn't really explain it too well. I probably just told you to put it in. List item retrieves an item from a list with the index of that item. So which indexes do we want? Which indexes am I talking about? If I want to subtract 4.25, if I want to subtract 2 from 4.25, which indexes do we want? 0 and 1, right? Perfect. Okay, good. You guys, I'm just trying to get you guys to give me obvious answers. I'm going to ask you obvious questions just so that you can see how actually simple this is. It is quite simple once you get into the nuts and bolts of it all. So if I plug my list in, all I need is to grab index 0, and then I'm going to show you a little trick. So this is going to give me 2. And then because 2 is my index 0. And if I zoom in, there you'll find, even without sunglasses, so this stuff here is sunglasses. So if I turn sunglasses off, I'll just show you what regular grasshopper looks like. That's regular grasshopper. You've got these little pluses. This guy here is going to give you I index +1, right? So that very quickly is going to give you index 0 and index 1 without having to do this. Okay? A lot of components have that ability. So you might not be aware of it, but you can zoom in to this one and add more inputs. Or you saw me do that with this one over here, right? You can add more numbers to the pattern for weave. So all we really need here is a simple subtraction. So we want to subtract 4.25 minus 2, in my case, which is 2.25. And rather than using a 1 for my Z value, I can use that value. And now it is impossible for me to have slopey stairs at the moment. So if I I'm just going to put this number, see this number, I'm going to use it to control both the series and the range. Oh, I turned off sunglasses, turn it back on. So if I plug in a 10, then I'm going to get 10 treads, probably not 10, 9 treads, and stairs that take me in between. 2, which is here, and 11, which is there. There, I think. Does that fix everyone's slopey stairs? Does that fit? Like there were some stairs that looked more like a truss than stairs, like Eric's. Yours was like a saw. It was doing this. Does it look more like stairs now? Okay, still on it. Okay, so the critical thing here is because this range is controlling the Z value, what I'm doing is I'm setting a minimum value, and I'm going to plug some number sliders in here instead of panels. So I've got a minimum value and a maximum value for my stair. Right, so that's setting, that number there is 0. So it's the stairs going from elevation 0 to elevation 10, right? But if I just quickly go work out this point here, 10, see 19, 19 is not at elevation 10, right? It's a little bit higher because these numbers here in the range, they're setting the point of the tread, and this last tread is then getting a vertical riser, which is in this case now 1.111 units high, and that's going up. So we want to do one last thing to our list. Sorry, that jumped around a lot. One thing needs to happen to this list until we make a polyline, and that is we want to get rid of that last point, because that last point is actually redundant. Okay? See this point here, number 19? Because I want to, if you think about it, our number slider, it's just because I'm getting a weird face. So our number slider is going from 0 to 10. So it's like we've got a stair that's taking us from 0 meters to 10 meters. But then if I actually bake this stair, that point there is not at 10, it's at 11.11, right? So this is the point that it gets to 10. So we could either delete this point or like in theory, like if you have a stair that goes from 0 to 10, this last tread's probably useless as well, right? Cool. So we want to get rid of either the last point or the last 3 points. Okay. So the opposite of list item is, where is it? What are you? It's over here. Cull index. So there's, well, it's not the opposite, but you've got, yeah, it is the opposite. You've got list item, which picks out the item at a particular index, and then you've got cull index, which removes items from a specific index. So here, at the end, I want to cull an index. Which index should I cull? It's literally like on the screen. So look, this is index 0. So which index should I cull? Yeah, 17, 18, and 19 on, yeah, right? So, or 19. Let's just do 19 for now, right? Are you sure about that? Like, if you look at your stair, which index should you cull? Is everyone doing exactly what I've done and they've got up to index 19? Are you sure? Yeah?
I mean, on the
Sure? Huh? Yeah, don't, no. I don't want you to have the same number as me. How many do you have? What's your, what's,
So I'd get rid of index 7, I think. I don't know, mine's got extra lines in their purple. Trying to hide something.
oh.
Yeah.
Oh, you've just got both, you put both of these in here when we wanted this to replace.
So this one should not
Get rid
be
of
there.
that, yeah, get rid of that.
Okay, so I get rid of
Okay,
7.
but the point is, Isabel has how many rises or treads? 5?
5.
Yeah, Isabel's got 5 treads, right? I've got 10, right? So I have to get rid of index 19. Guys, I've got to get rid of index 19. What index do you have to get rid of? If you've got 10, yeah, it's 19. But if it's 5, then you've got to get rid of 7. Yours is 19? Okay, I'm going to change mine just to make it so that you guys are all screwed. Okay? Okay, I've got to get rid of index 11 now, and you've all got to get rid of 19. So if I plug 11 in here, I'm in trouble, I think, because great, that worked, right? My stairs now go to 10, but what if I did this? I'm screwed, right? That does nothing. I do 16. I've got some weird, slopey bit in my stair, right? Okay, so when we talk about in Grasshopper lists, but I want you to think of these lists as wrapping items, right? Oops, I've forgotten the most important number. 0. So index 0, index 1, index 2, index 3, index 4, right, is the equivalent of this, right? That's how Grasshopper is going to show that to you in a panel, yeah? But this, if I start at index 1, if I'm going up 1, what do I get? It's very, very straightforward. I'm just trying to get you guys to think differently. So I'm going to ask very simple questions. If I go up 1, from 1, what do I get? Right. If I go down 1, oops, what do I get? Right. If I go down 1 more, what do I get?
-1.
Correct. Right? So, guess what? The first item in the list is index 0. The last item in a list is index -1. And the second to last item is -2. And the third last item is -3. Okay? These are the same thing. Right? Index in this list, index 4 is also index -1. And index 3 is also index -2. But if I had a list that looked like this, oops. Right? Index 0 is index 0. Index 100 is also index -1. And index 99 is also index -2. Right? So no matter how long your list is, these will always correlate. Last item is -1, second to last item -2, so on and so forth. So rather than getting rid of, index 11, let's get rid of index -1, -2, and -3. That needs to be set to multi-line. And look, it's gotten rid of my... Oh, no, actually, we don't want to get rid of -3. You were right. We only want to get rid of the last 2. So that gets rid of all of them up to the last 2. And we have a stair now that takes us from our starting point to our end point. I've got smiles, which is good. That means things make sense, right? No. Huh? Yeah. I've got smiles, that means things are going wrong. Okay. Did the looping list made sense, right? Cool. Yeah.
Wrong.
It can work. It can work, but that'll only that doesn't teach you guys the -1 thing.
Oh, okay. So it's okay then.
It is okay.
Okay, cool.
Yeah, I turned it off. Right click the panel. I wish panels were the other way. I wish they started as multi-lines. What? It is working.
Really?
Yeah, there's no... Just hide these. Hide these. And then preview the polyline.
Just do that?
Yeah. Yeah.
I have a question.
Yeah.
If we remove the points, so the number should also go off, right?
But you're not putting your point... the list that you removed points from isn't plugging into those 2. So if you plug that into those 2... Yeah. Don't hold shift when you do that. Don't hold shift when you do it. Do it again to that one. Yeah?
Oh yeah, it could be. Is this right on? Because isn't the whole point to stop at 28?
It is if you want your last tread to be the same height as where you want to go.
Oh, okay.
So if you think about it, stairs...
Like landing.
Well, yeah, so if you're going to a landing, we normally don't treat the landing as the stair, right?
That makes sense.
But some people do, and some people don't. It's up to you. You're the one making the rules here, right?
Yeah.
Yeah? Okay, we're 2 hours in and we've almost done a stair. Cool. Was there an Yep.
Getting rid of the line.
It is, but what you're seeing is you haven't plugged your removed points. Well, I haven't either. I haven't seen my cull index component. It's not plugged into it's not plugged into point list or point order. The point list and point order. Yeah, so if you want them to also follow, you've got to plug your cull index into those 2 as well, rather than using the... Yeah, so see that one? Use that. Yes, exactly. Does that make sense? Yeah. Yeah, exactly. Did that make sense? So look. See these numbers?
Yeah.
These are from here.
Yeah.
Right? So
Yeah, but then why are my lines in the right place? And then
pardon? What do you mean? Right. What do you mean by right?
no, never mind. Her lines are non-existent now.
Yeah,
Never
why don't you
mind,
have
I
lines?
think I've got it.
Can you click that? Okay, they're just not previewing for some reason. Oh yeah, it's because they're okay. So in her case, she's got this thing she's got a thing that's got a component that's showing an arrow between each point, right? You don't. Those arrows are on top of her line. Yeah?
Yeah.
No worries. It's getting a bit chilly. See, I smell. I'm gonna start smelling. Five easy. Jeez.
I'm trying to write notes for myself everywhere. It's sort of helping.
Is it making sense?
Yes.
Making sense? Yeah.
It should just be -1, right? If there was a null.
Yeah.
Get rid of the last
Not
one.
or. No, it
Oh,
depends.
as in,
It depends. Right?
as in you have -1 and -2.
Yeah, why? Why have I chosen that? What does yours do?
You get rid of one.
Yeah.
But if you get rid of both of them, then what you still
Where's your slab? Where's your top of slab?
Oh, you want to rise it to end.
You want a riser there, like there, right?
Oh.
Because your slab, like if your slab's at that height, why do you need a landing? Sorry, a tread.
Oh, okay, I understand. So then we don't have to get rid of it.
You don't have to.
Yeah, okay.
It's up to you. Okay?
Okay.
Yeah. It's a lot of this stuff is going to be up to you.
Yeah.
If you're someone who wants to put a tread coming off their slab, go for it. Like some designs do that, right? You might have a landing. Like if you don't have a landing system in this, then some landings will have like that extra tread off the end. So. Is it making sense?
Yeah, we got it.
It's making sense to everyone? Yeah, cool. Making sense to you guys? Cool. Hello. That looks good. That looks right. That looks good. Does it make sense?
Yeah.
Good. Okay. Cool. Notes. Oh, 10 o'clock. 4 more hours.
So you don't have to go home and watch it again to make it actually
You can see why if I was like, okay, you guys have to use Grasshopper to do your design, how like you guys are going to regress back to like kindergarten level designs, right? Like, oh, we've drawn a zigzag and it took us 2 hours. It's like, why would you want to spend 2 hours learning how to draw a zigzag? But now, what potential does this have? It's got a lot of potential, right? Yeah. Go for it. How about this, guys? How about we have like a 10-minute break, right? You guys can stick around and ask me questions, or you can go get a coffee or go to the toilet or whatever, okay? Because we've got another 4 hours after this.
To make one mistake.
No, we'll have another break. What's the difference between what? And? No, they're different. They're totally different. Let me show you. Hello?
Have you taken the attendance for today?
No, I haven't.
And then is it starting from 8?
Yeah, well, yeah. So no matter what, this class will start from 8. Either the lecture will start from 8 or the tutorial will start from 8. So if there's no lecture, we'll start from 8.
And then how do I check if there's any lecture on?
I don't know. I have no idea. Jennifer has a schedule for the lectures. It's not up to me. It's up to Jennifer. So maybe someone else will know. It'll probably be on the Canvas site.
I was trying to find it yesterday.
Pardon?
I was trying to find it yesterday.
Okay, so I'll get Jennifer to put it up.
Yeah.
Okay?
Small question.
Yes.
I don't really know how to explain it.
Yes.
But is there a way to make the boxes in some type of grid?
No.
No?
There's this. Okay, so you want to be a bit OCD. Is
Yeah,
that
yeah.
okay? Why doesn't it line up? So that you can do this. You can. There are these little components.
Yeah.
See these? So these will do like they'll do like alignments. Like aligning in Illustrator.
Yeah.
And you can also these guys. This one here is like it's a spread.
Okay.
So yeah, you can do that.
Yeah.
But if you want to be OCD,
Yeah.
I've got some other. I'll show you. We might talk about something later that might help you,
Yeah.
where it's just text.
In text.
If you want to do this all as text,
Okay.
you can.
Yeah. Okay.
Yeah.
Yeah. I will try.
Because what it will look like is. So see that series?
Yeah.
That might be so. That'll be our tread X spacing, and that'll be a range. So it'll be all organized as text, right? Rather than it being like if you want to work if this is better for you, then I'll show you how to do it.
Okay.
Okay?
Yeah.
So we'll learn this today. We'll do this today, yeah.
Okay.
Yeah.
Yeah, that would be perfect.
Cool.
Okay, thank you.
No worries. Hello.
Just to speak one thing that I mailed you regarding
Yes,
that
yeah.
But I mailed you on the canvas probably on the initial.
Just
then
stop
after that-
mailing me on
I know,
Canvas.
I got
yeah,
that.
yeah.
So I just mailed on
Do you want to work by yourself?
But I think it will be too much at the end. If
It won't. It'll be the same. It'll be the same.
Okay, so I think I'm pretty much okay
Yeah,
with it. Yeah,
yeah.
That's better.
Yeah. No. So an individual will be expected to produce an individual's amount of work.
Okay.
Cool.
But it's not more of like it won't be more burden, right?
Yes. No.
It will be the same, right?
I want this class. I wanted this class to be an individual class.
I know, yeah, that's
So
what
if
I'm
two people are submitting work, they're going to be marked as if two people have submitted the work.
Oh, okay, got that.
Cool.
Yeah. Thank you.
No worries. Hello. Okay. We're gonna do Python. I reckon we're gonna do Python. Okay. Because they've got to start using it later. So my idea was like we would do the component node in code. We'll do node in code. You know how Grasshopper lets you write Grasshopper code as if you're using Grasshopper components. So that way, at least I can go, hey, look, yeah, and then maybe that might be an easy way to get them into Python. Then you've got to use like this and learning Rhino script syntax and okay. So list item takes one item or a number of items depending on what you've asked for at the index and returns it, right? So here. So this is index, by default it's index 0. So that's returning index 0, which is A, right? Graph tree doesn't do that.
Why is it picking the second one?
And the third one, because that's what graph tree does. And I haven't explained graph tree properly, but they're not the same. They are not the same. So don't use graph tree to pick items. Graph tree will always return the same number of items that you put in, right? So if you put 3 items in, there will be 3 items out,
So what
right?
do you use it for?
What's the difference? What can you see that's different?
It's assigning the first index to all the items.
Yes, but what's difference between this panel and this panel?
It has 2 coordinates.
W-
Like 0 and 1.
Yeah, this thing, right?
Yeah.
Yeah, these are called branches. I have not explained what branches are to you guys. I will.
Okay.
It requires some time to explain, and I know you're curious, but it's not going to take 7 minutes to explain it. Okay,
Okay.
but I will explain it. And the what I find is when people teach them, they don't teach them properly, and then people learn the wrong way. So I want to make sure you guys are taught the right way. Okay?
Okay. But this makes it clear now.
Yeah, it's not. This is not list item. Yeah.
Okay. Yeah. Thank you.
No worries. What should we do? People are worried about landings. Yeah. Okay, I can either do this. We can do stairs. Continue with the stairs. Extrude them. Like, there's no point. Exactly, yeah. We move on to Python. Get them started in Python. A lot of them are going to resist it. I don't want to. That's a lot. That's a lot to rewrite in Python. But maybe just explain a few things of Python. What can we do with Python? Maybe what I'll do is let's make a truss in Python. Huh? Yeah, it will be, yeah. Yeah, it will. I'm going to be teaching Grasshopper Python, so that way they can get familiar with Python. Yeah, so we will, but I just want to get them, I just want to start them, put the little floaties on their arms, because later I don't want them to be scared of it. We can, but we might start with Python. We can't do Python 2 and Rhino 8. It won't be backwards compatible. Neither of these components are backwards compatible. Neither of these two are. That's something else. That's a plugin. Yeah. So they've completely replaced the IronPython component. Yeah. Well, let's.
We're going to use it once you why would you use 2 over 3? I mean, if it doesn't go compatible.
Because you might have a script that's 2. You might be developing it in 2. Huh? Yeah. But they haven't made these backwards compatible with Rhino 7. It's not backwards compatible. Yeah, you're right. It's at least what you can do is you can copy the script. This is their way of forcing people to buy Rhino 8. No. They're not like that. I think a lot of people one percent of Grasshopper users are using Python. I reckon. No. Maybe 5%. What? You mean they replace? I don't think it's. There are some of it is not. Some of it's not good. I feel like the geometry importer is really slow.
I like how you can regex layers though.
You can regex.
As in, you can do it straight through.
Yeah. No, you're right, but this component, where is it? It's this one, right? this seems to this runs no matter what. So whenever I edit the Rhino model, whenever I edit it, even though I'm not picking a layer, that runs. Yeah. Yeah, so it slows the whole script down. Whilst with human and elephant, if you change objects on that layer, yeah, because this thing, yeah, so they might fix it, but in this case, it's really like it's made my scripts really slow.
Usually I just like use it in the oven. I've got all my things set up.
Yeah, but if you know our like Fizo scripts and stuff that are trying to run, like that just doesn't work for us.
That's unfortunate.
Yeah, but when I get around to it, I'll complain. I'll be like, "Nah, fix this." The other thing is it doesn't have the geometry filter in it.
Yeah, I didn't like that.
Yeah, it needs a geometry filter. I want to be able to just say, go get the curves from this layer. I don't want to grab everything. Because there could be like thousands and thousands of surfaces. And then I've got to go clean up my Rhino model. And I'm like, no, just... Yeah. So those are two things that they could fix. If you're listening, Rhino, to this video, fix it. What else? Yeah, I just noticed it's a bit slow, but I am using it for baking. The baking stuff's really good. And I don't need, but the baking thing's. I think and especially because you have baking for like hatches in the hatch component rather than in its own. Like you've got to bake things very differently, and then this one is like everything. Not even layers. Like baking layers in is through the exact same component, and then the other good thing about it is that it has really good. It's got a really good protocol. Like when you add that action, that's the equivalent of hitting that button, right? So that you can put that as an input rather than and then so you can have true, false, but then there's also purge, pull, push, and bake. So pull is pardon? Because of the egg, because it's like, it's baking. It makes sense. Because it's lots of bakes. It can be lots of bakes. Oops, I can't. Hang on. Does that, will that actually work? Okay, that's it. And then we want to do this. So, true is push. Right, so that's push that in, right? And then oops. Ta-da! Yeah, it's pull. Yeah.
It's also nice that you can do stuff and the model still has the geometric data on it.
The what?
You can still do stuff and the data still retains it.
Yeah, what it does is it's actually editing the object. So what you baked in, rather than deleting it and putting a new one, it actually replaces it. So you can use this to modify existing components. This thing's gonna kill it. It's gonna do really well. I love it. It's so good. This is me talking to Danielle. We're geeking out over stuff. Yeah. and now that Python and the package manager is working, we'll start doing cool things. Like we can start giving people Python scripts, Python 3 scripts. Yeah. And then you're like, what? Okay, what's the first one we're gonna write? It's like, which one? The first one I'll do is we'll test PDF output for SVGs for Redback. Huh? No, as in Redback will output a PDF rather than a SVG. Yeah. Well, I don't. Most people won't. They'll be like, "What?" But it's very useful. If I gave that to Maddie, she'd like that. I think she'd like it. Huh? It'll be the exact same thing as the SVG, but it's a PDF. It's usable more. Like people understand PDFs more than SVG. Yeah, but if it's got a PDF, it's like, oh, yeah. Oh, whatever. When I said 10 minutes, 15 minutes ago. So it is, and as well, I don't feel like I'm bothering other people as well. Huh? Is it? Oh. Ah, yeah. Someone's adjusted it. Doesn't matter. Cool. So I want you guys to get started on a pathway towards also using Python. Python kind of requires its own class in a way. Like if you want to learn it properly. So what I'm going to do is we're going to sort of cheat. Okay? We're going to learn Python but also learn Grasshopper at the same time. So in Grasshopper we can write Python. And so I can introduce you to Python in Grasshopper using components, Grasshopper components in Python, and hopefully that'll get you guys understanding Python, but we can also continue learning Grasshopper. Does that make sense? Okay. We're going to make a truss with Python. The type of truss, I think it's called like a Warren truss. It's been a while since I've named trusses things. We'll make a Warren truss. Warren truss looks like this. And actually, if you want to make them function properly, like if this was a bridge, then you kind of don't need this. But we'll actually draw it with that. So let's pseudocode this out together before we do it, just so that we know where we are. And we think about some of these components that we've just used as well, okay? So we're going to just start with the two curves. We're not going to code them, but if I've got these two curves, what is the steps I might need to take to make this Warren truss? You just saw it. So add points. Can we be more? Yeah. So yeah, adding points. But another way of saying that is we can divide the curves So we want to define how many divisions we want. And then what's the next step?
Giving direction.
Pardon?
The direction.
Direction. What does that mean? Like this?
Yeah, from point A to point B.
Okay, so how about this? I'll say this is A and this is B, right? Now you guys are going to start seeing things very similar to what I drew before. So if this is index 1, yeah. So where am I drawing from?
A02 B1.
Right, okay. And then
B1 to A2.
okay, so another way of saying that is we want the alternating points to connect to the opposite alternating points from A to B, right? Does that make sense? Cool? Oops. And then we're done.
No, B.
Pretty much. Like, if this was actually a proper Warren truss, we would just want to make sure that we have odd number of index points, because that, like, ending in that direction is the proper thing to do. But that's about it, right? Really straightforward, okay? This process of taking these lists and using this index and then this index and this index, what component did we use to do that for the stair? Weave? Yes? Perfect. But what do we have to do prior to that here? Yeah, we've got to get rid of this guy, right? And this one. We've somehow got to, like, pattern-wise, remove these. So the process of removing things from a list or sending them in different directions is the opposite of weaving them. You know, you're taking a list and you're just dispatching it or dispersing it. So we're going to learn dispatch, which is the opposite of weave. But yeah, we use a combination of dispatch and weave in this case. We're going to write the script in Grasshopper, but then we're also going to write it in Python. Okay? So it should be really easy script to write. So let's just do a new script. We want 2 lines in Rhino. I said we were going to do finger joints, but we won't. This is better. You can tell my lesson plans are kind of made up on the spot. So I know what I need to teach you, and then we decide what we're going to teach as we teach it. So, because, you know, things have got to change. You've got to be agile. Don't tell Jennifer. Hi, Jennifer, watching this video. She's probably laughing right now. Now, Danny, what do you think? Should we do flat Grasshopper, just straight Grasshopper and then Python, or weave Grasshopper and Python at the same time? Huh? Flat? Yeah, otherwise people's brains might break. Yep. So we'll start with Grasshopper, and then we'll do Python. So you guys have 2 curves. Shouldn't take long to do that. Oops. We want to bring those 2 curves into separate curve parameters in Grasshopper, and I'm just going to do it like I'm going to set my Grasshopper up to kind of be the same as the script. So the bottom curve will be the bottom flange of the truss, and the top curve will be the top flange. So we want to divide our curve evenly. Fortunately, there is a nice component that does that. It's called divide curve. You can find that in the curve tab under division. Let's divide curve. And we're going to divide our curves separately because we want to keep the lists separate. We want to manage that. We don't want to treat them the same, but we do want them to divide the same number. So when we get a number slider, we want to make sure that number slider plugs into both division values. Cool. So right now we're at this point where we've got these points with and each of them has got their index. We want to draw a line between these 2 points, right? So dispatch is functionally similar to weave, except it does the opposite. So what it does, it takes a list and it takes a pattern. The pattern that this takes is it can take zeros and ones, but the input that it takes, it says it takes these things called booleans. Does everyone's probably heard the word boolean if they know Rhino? But you think of it as something totally different to like making patterns, right? When I say Boolean, you think, oh, that's like cutting objects away from other objects or joining objects together, right? That's what you hear, right? That's not what Boolean is as a fundamental thing. Boolean is actually Boolean is a name. It's a dude's name, I think. Let me just double check. It's been a while since I've talked about this. Yes, it comes from this guy, George Boole. So yeah, George Boole has Booleans have been named after George Boole. Boolean refers to this object type which is either true or false, right? So if we say, okay, there's a statement like, is this a computer? The answer is going to be a Boolean answer because I've asked that. Is it a Boolean computer? Is this a computer? Yes, so that's true. It is. So dispatch takes these object types called Booleans. Booleans can be represented many ways. They can either be represented with this thing which is true or false, which is not text. It's an object which is either true, it embodies trueness, and an object that embodies falseness. But it can also be represented with numbers. So the number 0 will always represent false in that case. And the number 1 will represent true. But in that system, any number other than 0 is true. Okay? So 0 is false. Any other number is true, but we can just fall back to 1 as being true. So if I had a Boolean, so here's a Boolean toggle, and I turn that Boolean into a number, an integer, I get 0 for false and true for 1. Okay? Cool. Or it could also be represented via text, true and false. So if you type text in, I think, oh, actually, I don't think, maybe it doesn't. These will both be true. Oh no, good, it converts it. So that will take text and turn it into an actual Boolean. So that these look the same, but in this case they're not. So, but what we'll do is we'll just use this panel. So 0 is true, 0 is false, 1 is true. That is going to dispatch trues to A. And so if I mouse over A, it says here dispatch target for true values. And if I mouse over B, dispatch target for false values. So this pattern, 0, 1, is going to output this point here to B, and this point here to A, and so on and so forth. So if I preview one of those lists, you can see it's giving me that pattern of the odd points or the even indexes. And this one is going to give me the odd indexes.
Do we need 2 separate points?
Pardon?
Do we need 2 separate points?
So what we're going to do is we're going to use this dispatch for both lists, right? If I use the A output for both of these, we're not going to get the alternating points, right? Like if I just do a quick line between those, we're going to get the same points along that list. So what we want is we want to make sure we use a different output from that dispatch, and we'll end up that's giving us the alternates. Yeah. So in this case, the way my pattern's working, I want this bottom flange to start with B, and the top flange to use A. Now it looks like we're almost done, right? Because we've got like 1/2 of the webs, but rather than using line, we're going to try and use polyline again, like we used it for stare, the stare function. So if I want these two lists to relate to each other, like I did with the stare, what can I use? And I don't want you to answer. I know you guys know. You guys know. What can I use to bring these two lists together? Huh? Exactly. You were going to say that too, right? Yeah. Cool. Now, one reason why I didn't write true and false here is so that I could use it with the weave. Okay? No, you can't. Like if I merge this, merging is the equivalent of holding shift and dragging. So look, I'll just show you what that looks like. Come on, you can be bigger than that. So merge is just the same as if I do this. So I held shift and connected that there. If I plug that in, it's no different, right? So that merge is the equivalent of that, just so you're aware. So if you're ever having trouble with the order in which you're dragging those cables in and you want to control their order, you can use the merge component. So that is going to be very different to that, right? Now, in this case, we can control the pattern. So we're going to control it with this panel. So we're going to use the exact same pattern here as we have for the dispatch. But 0 is going to be outputting to false, right? So false is equivalent of B for this dispatch. So we're doing some really quick conversions in our head. 0 equals false, false equals B. So our B output should go into which input? 0. Correct, right? And therefore, our A output should go into our 1 input. We have a weave, which means we should be able to throw that into a polyline, and bang, we've got our Warren zigzag. Super easy zigzag drawer.
But we need to end it to the bottom.
Yep, we will. We'll just get people there. Well, how do you think we're going to do that?
To add one more point to the bottom.
And how are we going to make sure that happens?
By changing the number on the bottom
Right.
curve.
So guys, I'm currently dividing my thing by 7. You'll notice I will put mistakes in my script on purpose. So please note, I made it 7 for a reason. So 7 is getting us up to the top. We need to get down to the bottom.
Move it 8 and it becomes.
Exactly. If I move that to 8, what's it going to do? It's going to go to the bottom. So what does that mean? We want even numbers, right? So let's make sure that this script can never do the wrong thing. Let's double click this number slider and make sure that it's only producing even numbers. And now, it'll always go to the bottom, no matter what you put in. It's funny.
Nah, I feel like clapping for this.
Cool? Yeah. And the other thing is, the other reason why I do that, because otherwise, like if I give you guys like a perfect script, I don't think you'll learn, right? So you learn by making mistakes. And the other thing is it shows you that you can always go back and modify your script, right? This is great because if I started this process off manually and I divided by 7, and then I spent all the time drawing those lines, I'd have to go back right to the beginning and redo it. By mapping out my process, I can go and change the choices that I made without any extra effort. It's worth the effort. It's worth it. Start using Grasshopper more. Okay, that was super easy script, right? Is there anything else we want to do? I think that's enough. Like, you guys don't have to. There are some reasons why we would want to do more, but I reckon that's enough to get you guys where you want to go. Let's just, like, Warren trusses kind of want to have verticals in there as well. So we'll just throw these divide curves into into a line between an A and B, and now it's looking like a bridge somewhere in the countryside. Maybe even like over an expressway in Sydney. I'm sure there's bridges that look like this. Let's just make this slightly cooler. Why not? Oops. Let's replace this guy. Too fast? What I did was I just quickly drew a curvy top flange and replaced it. So I just went set curve loop. I'll do it again. I'll do one like this. Bad. This is a bad truss, by the way. You hate it? It doesn't look good? Oh, when they do this? Oh, you mean the wires? The wires? Okay. Well, if you have OCD and you want your Grasshopper scripts to look organized, then maybe you don't want to use Grasshopper. Maybe you want to use something else. Maybe you want to use Python. So I'll show you. We're going to do this exact script in Python, okay? And you're going to see how organized it will look compared to Grasshopper, okay? Now, this is where I draw the line between, because I'm a visual person. I like when I'm designing something with code, my brain is trying to work visually, and I can see the thing that I'm designing, and the script that I'm working, the Grasshopper script, it's a visual thing. I remember where my components are, like as like locations, right? Like, oh, that, like this little cluster here is where I did the stair, and this little cluster here is where I've organized my data. That's just how my brain works. It's how that's why I like the icons rather than text, because I'm just visually reacting to that. You might not be that type of person. So I'm not saying this is the right way, it's just the right way for me, right? Python is it's the thing that I find it really hard to visually design with Python, because Python is like a text editor. But if your brain wants to work that way, then let's do it. Let's show you guys how to do that. I love working in Python. I love working on it for specific problems, especially problems that aren't visual, but maybe it might be the right thing for you. So everyone here is using Rhino 8 right now, right? On your computers? Some of you are using Rhino 8, some of you are using Rhino 7. Okay, cool. If you are using, either way, you can go and grab this component called, it will be called Python in the Rhino 7 users, and it'll be called Python 3 script for Rhino 8 users. Now, this is one of those components which you can zoom in and you can change the inputs, and it's one of those components that you can also double click and it will bring up a special dialog. And this is a Python editor. Who here has experience doing coding? Even high school level coding? Okay, cool. Even Java. 1, 2, okay. Okay, this is going to be a little bit boring for a minute or two. Okay. This is a text-based programming language. Python's probably, I think, the easiest one to learn, because it's just formatted nicely. It's probably hard to read. Do you want me? I'll work out how to make this font bigger. How do I make a font bigger? I don't think I can make the font bigger. Okay. We are going to use something else to write Python. I will use something else to write Python. You guys don't need to use it. This is a text editor called Sublime Text 3. I love it. It's super useful. If it's free, like the guy wants you to pay for it, but he has a free version, like a free license. Yeah.
You can change the font in Python.
Can you?
Yeah, it's in options.
Is it? Not in. Are you using Rhino 8?
Yeah, options and font.
Oh, there it is. You got it. Thank you. Now, do I want to change my font? Because this is my computer. I don't want to. No. I'm going to still use Sublime. I think that's still a better thing. Keep changing my mind. I keep convincing myself. Okay. No. Huh? I know, it's just annoying. I have to do it every Tuesday. I've got to change it back. It's annoying. Whatever. Okay, is that readable? Do I need to make it bigger? Readable? Okay. Do you want me to make it bigger? Can you go to the optometrist? You might need to go to the optometrist. How about that? Is that readable?
I'll try my best, sir.
Don't call me sir. Don't call me sir. You found my pet peeve.
Sorry, sir. Thank you.
Do you know who else worked at McDonald's?
Yeah, I know everyone worked at McDonald's.
Danny used to work at McDonald's.
Really? The same one?
No, not the same one. Okay. So Python, if we think about Python similarly to Grasshopper, in Grasshopper we define variables, right? Remember those parameters that we use to go grab a curve from Rhino? Think of those as variables. You need variables for your script to function, otherwise there's nothing to work with, right? So in Python, you can set variables by setting their name. So in this case, actually, let's just go variable1 equals, and then you can type in what you want, right? Python is going to force you to think about what type of object you're working with. Just the same way that Grasshopper does. When I said, hey, I would like a curve from Rhino, I am saying this is a curve. That's the object type that I'm working with. And Python has its own way of defining object types. So they are, and I'm going to put them in like this, strings, which strings are text. Strings are defined by putting quotes around them. If you don't put a quote around something, then Python is going to think that you are referencing a variable, and I'll show that in a second. There are integers. Which you just type in what the number is. So in this case, if I type 1, it'll take it. There are these things called floats, and I'm just going to write float number for now because float is a special thing in Python. Floats are numbers, natural numbers. So you remember how we were talking about number sliders? You can do an integer, you can do a float like with a decimal point. So floats are, you need to put a decimal point in, or otherwise it will think it's an integer. And then there are more complex things. So you know how Grasshopper we're working with multiple items? That's called a list in Grasshopper. You can have lists / arrays in Python, and they are defined by a little square brackets. And then, so this list is an empty list, but I can have items in that, like that, 0, 1, 2, 3. And then the last one that I will touch on is a dictionary. Dictionaries are like lookup tables. They are defined with curly brackets, and they are made up of strings that define keys. So like if I'm going to make this an actual dictionary, let's do this. So that is a dictionary object. So it's got a key, architect, and then a value, which is the definition of the architect, right? And those functions really, like these two objects here, array and dictionary, make up quite a lot of the powerhouse of computer programming. So if you can iterate over an array, you can iterate over dictionaries. Dictionaries can contain sub-dictionaries, so I can have a complex dictionary which is like A equals a list, and that list can be, so that variable there is a list, but that list could have also a dictionary in it, which has then got its own sub thing. Like things can get really complex, right? Using that system, right? We don't have to go into it too much, okay? But we just need to know how to interact with some of these things. So I can what you can do is you can then run calls on these variables. So I can say, hey, a new variable which is going to be an addition result equals integer. I probably spelled integer wrong, but whatever. Integer plus float number. Right, so integer is this value here, 1, and float number is this value here, 1. So addition result is going to be the result of those two being added. So the equivalent of a panel, you know how we were using a panel to look at stuff in Grasshopper? The equivalent of that in Python is print. So you can write print. You need a little parentheses after that. You can print whatever you want. So in this case, we can print addition result. And after playing that script, you can see down here in the terminal, unfortunately, I can't make the terminal larger text, but there we're getting the result, which is 2. So that's integer plus float number. And I can print anything pretty much. So I can print string. And now when I run the script, it's going to print the addition result, and then it's also going to print string, which says text. Cool? Do I need to repeat any of that? Or it's pretty straightforward. This is not architecture in any sense, okay? This is just, introduction to Python. We're going to go more into Python, but really what I want to do is get you guys familiar with Python so that later when we're going to go download other people's Python scripts to do things like AI, that we're not scared by opening up the Python file and it's got all the, it's defining variables and it's got all these, things. At least you guys kind of recognize it. So that's why we're doing this. Huh? Yes. Yeah, so watch. It matters. So that's just how I write my variables. You can't put a space in a variable. So float number can't have it can't have a space in it because then it thinks of this as a separate thing to this. So I put in a capital for every word after if there is a space, so I can tell. But it doesn't have to do that. It can be that. But this thing's going to be super OCD, okay? If you don't type the thing right, it's not going to pick it up. So in this case, it says name addition result is not defined. So it can't see this variable because it doesn't exist. It needs to be exactly what I typed in before. And a lot of your fixing up bugs is probably going to be just typing in the wrong thing. Just because, in a way, I'm organizing my script in that I've set a bunch of variables and then I've put a new line and then I've done a function and then I've done a new line and then I've done my prints. It's purely for organization. So one last thing before I get into writing Python for Grasshopper, the hash symbol is what is used to make comments. So you can add comments throughout your script. So for example, you can just put a bunch of hashes in just to organize your script. That's not going to affect the code. It's going to skip over that. But if I used anything else, it's going to error out. It's going to be like, what the hell is line 7? Invalid syntax, right? So if you want to use anything other than a hash, you've got to put a hash before it. So I can write here defining variables, and that won't screw up the script. Cool. So this is what I meant. Some of you find Grasshopper disorganized or messy, you can, if you want, you can just write it all out in Python. You probably don't want to do that, I can tell. Okay. So Python allows you to load in other people's libraries. So rather than having to build your own functions, rather than building your own functions, other people have made... How about I do this? That didn't know. Okay, so we can load these libraries in that other people have made, because at the moment, if you want to, like, let's say I wanted to use this to do like build a surface, like a Rhino surface or a mathematical surface. At the moment, this is vanilla Python. I would have to start from scratch. I would have to create my own syntax for defining what a surface is and build all these functions in. It would be thousands of lines of code, right? And we don't want to do that because someone's already done that and we're paying for it, right? The Rhino license gives us access to all of that processing power that McNeil have made. And so that is done via an import function. So what you'll probably notice in most Python scripts that you'll see, there'll be at the beginning of the script this point where people are importing other libraries. And so we can import things like Rhino script syntax. And then what that means is when I type Rhino script syntax, I can access these functions that are inside that, like add box or add arc, or like there's thousands, right? Is point light, object layout, so on and so forth, right? So one thing we can do, because it's really annoying typing Rhino script syntax over and over again because it's quite long, is we can import things and give them shortcuts. So if you go import Rhino script syntax as rs, now when we type rs, that gives us access to it. So it's a nice little short way of getting access to that. I'm going to keep repeating myself. And we can also, if we only want specific functions from a particular library, you can say from Rhino script syntax import add box, and then we can just type add box, and that'll function as the add boxing. But we don't need to do this one. So the thing that we want to import for us to function, to actually get access to Grasshopper components inside Python, is this thing called the Grasshopper Python. What was it? Python import Grasshopper. Why isn't it showing up? GH Python, maybe? Hang on. It's not showing up. Grasshopper node encode. GH Python lib, that's it. I almost had it. Okay, so what we want is GH Python lib. This thing is not going to be very, like, Python is not very user-friendly regarding what libraries exist. Like, you need to know which libraries there are and then go get them. It's not going to help you. So we want to import GH Python lib. Within this, we want to grab this thing called components. So GH Python lib.components and we're just going to use a nice little shortcut, which will be GHC, which stands for Grasshopper component. So the variable GHC now contains all the Grasshopper components in the ribbon inside it. So if I hit dot here, we can find what was it? We want to divide curve, right? So look, there's divide curve, and divide curve takes a curve, an integer, and a boolean. Like it literally is exactly the same thing as this particular component. It's one-to-one the same. A curve, a division number, and then kinks. Everyone here has used Excel, right? Have you used Excel to the point where you've written a formula in Excel? Like sum, right? So in Excel, if I want to add some numbers up, I go sum, and then we pick the cells that we want, and it'll take all of them and add them up. Yeah? The way Excel writes formulas is very similar to how software coding writes functions and puts arguments into functions. So this here in Excel is called, or in any coding environment, it's called a function. It's the sum function. And the things that come after it in the parentheses are called arguments. And if we look at a Grasshopper script component, jeez. We have a function, and arguments. Okay, so the inputs are regularly referred to as arguments, and these are regularly referred to as like results or return. So these are the values that the function returns. So whenever you hear me say return, I'm referring to the output. Okay? So the anatomy of Python is you have your function, and if that function takes more than one input, so for example, if sum for some reason took more than one input, then it is separated by a comma, and then you have your other input, your other argument. So in this case, divide curve takes 3 inputs, but we only really care about 2. We want the curve and the number to divide it by. So all of you should have divide curve by now. What we're going to do is we're going to plug, why does that always happen? We're going to grab our 2 curves that we're getting from Rhino, and we're going to plug them into X and Y. And if you right-click X, you can rename it. So in this case, I'm going to call this top flange, and I'm going to name the bottom one bottom flange. So just to demonstrate what we're getting, if I print top flange, because the way this works is if you define a variable on a Python input for Grasshopper, it'll set that text as the variable within the script. So I can access that via typing top flange. So you can see here, that's the ID of the object of the curve. Top flange, and if we have a bit of a bug, I'll fix that in a second. But that is that curve. So my top points are going to equal Grasshopper component divide curve we're going to plug our top flange into that, and we are going to divide that by a number. We can either put the number in here like 10, or we can set a variable. So we can say truss division equals 10. And then we can use truss division as the number to divide by. So if I print my top points, we're going to get a few things. I'm gonna wait till everyone gets to this point. How about that? Just so that you guys aren't catching up while I'm trying to explain stuff. This is a lot slower to copy as well, I find, right? Because you're just typing stuff and so I've got to slow down. Is what I'm trying to say. Tell myself. The hash, it's comment. So I can put in my script, I can hash like this is dividing the curve by a number. Yeah. It's comment. It's comment. So as long on a line, from wherever there is a hash, it will ignore everything to the right. So if I've got, if I want to stop this line in the script from running, like turn it off, I can put a hash at the beginning of it and it will stop. It's a long day. Yeah.
I'm still getting an error.
Yep, you're probably getting an error like me.
No, only it's red, not white.
Huh? It's red? It's red. Okay, so your error is... that can't have spaces in it.
Oh, okay.
Be careful with spaces. You don't want to put spaces in things unless they're strings. Yeah?
I got an error as well.
You don't have divide. Oh, so it's not import grasshopper. It's import gh-pythonlib .components. Yep. Dot. There it is. Components. Yep.
Okay.
That should have it now if you press play.
Right. Okay.
Cool. Yeah. What's the error say? Divide. Scroll down. Okay. Addition result. So you're printing addition result, but we deleted it.
Okay.
So just get rid of that. And now print.
Print string also we need to get rid of it.
Where is it? Line 8. Just don't. Yeah, it doesn't have. Yeah, just comment that. It's probably the space that you've got at the beginning of it.
Like because he put 10 here before.
What? Oh, did you get? Why is print gone? It doesn't like print. What? That's really strange. Unexpected token. Print. Oh, I know what you've done. You didn't close this off. Close that off. Okay. Now, top flange is not defined. So you're printing top flange here, but it's not. Yeah, it's going to be really specific. It's got to be spelt exactly the same. Yes. No. Don't be sorry. Yeah, everyone's going to have these. Okay. So what is? If you mouse over the red,
Yeah,
that
invalid
thing.
syntax.
12. So it says 12.
Okay.
So there, you got equal. Oh, just get rid of
okay,
my
so-
Excel thing. That
Oh,
was.
is that all?
Yeah. Yep.
Rerun it or something?
Now what is? Yeah. Press play. Now what? Now what? What's the next error? Mouse over. 14.
Oh, yeah, okay.
Cool.
Okay.
Okay, so you see why you can see why I'm saying that this is
Yeah.
OCD
Yep.
because this thing's OC. This is like
Alright. Alright.
strict, very strict.
Cool, thanks for that.
What's your error? Invalid
no.
syntax 1. Okay, on line 1 you've got string text, but there's no equals.
Okay.
And you need an equals. String equals text. Yeah, that's it. Yeah, that's good. That'll work now. Yep, press play. Now what's the next error? Go to problems here, it'll tell you. 527. So line 5, just at the end of your dictionary, you haven't structured your dictionary properly. Just delete that whole line. Just delete it. Hey guys, this is just as a reference. This thing up here, I feel like it's probably screwing up some of your scripts. So you can just go up here and delete it. Just get rid of it. We don't need it anymore. That may end up making a whole bunch of these scripts work if you just delete those variables. We don't need them. They were just there as a reference.
It is saying module GH.
Yeah.
It is.
Addition result. Just get rid of that. Get rid of that.
Okay.
Get rid of it. Like, just delete it.
Okay.
And that. Delete that as well. Delete. Go. Now, what's wrong with you? Ooh. Components. Yeah, S.
Should it be?
Orange. It should be orange. Yeah. It'll just read what the error says. What does your error say?
Warning, divide curve.
Yeah. What about it?
Various argument deducted from default position 2.
Not deducted.
Oh, deduced.
So all it's telling you is the kinks value is not defined. So it's just warning you that it's using a default variable for that, and we'll fix that up in a sec. All good? All good? Everyone's... Oh, there's a red not working over here. What does that one say? Number 1. See that one there? Okay, so on line 1, see that text? That needs to have a quote at the end. Yeah. Try that. Press play. Play. Green play. Yeah, press that. Okay, line 5. You've got nothing there. Just delete that whole line. Just get rid of all of it. Now hit play again. Line 6. Okay, just delete all of that line as well because we don't need that. Yep. Let's go again. Okay. So look here, top flange. It's saying there's an undefined name top flange because look. See on my component, I've put this. So if you right-click your X value, you can rename it at the top flange. Cool. Cool. Okay, now do you have anything plugged into that input? Like scroll that way in Grasshopper. Yeah, so you've got to plug your curve into top flange now. See how I've got... So I've plugged them in. Cool. Hello. I love it when the errors are that large. What is this complaining about?
I was using like Rhino 7.
That's fine.
before.
It should work.
Yeah, and I copy paste all the.
Let's just delete all of this. We don't need that. Okay, and that. We don't need that. Okay, this is good. This is... Ooh, no, it's erroring somewhere. Top points. That's... What? That's not good. You've defined it again. Look, see import gh-pythonlib.components as GHC.
Oh, I see.
You've done it again.
Yeah.
Import gh-pythonlib as GHC. So this is replacing that. So that's why it's missing. Now it's working.
So, but if we have that line here, that is supposed to replace that. Right?
Look, this is a variable called GHC, and now you've defined it again. But you've not done the components, so that's replaced it. Yeah.
Oh. Yeah, thank you.
No worries. This thing's super specific, right? It doesn't care what, like, if you type the wrong thing, it'll break. Okay. Is it broken?
Oh, no, we're just talking about...
No, sorry, I'm talking to her. Pardon? When to use square and... Like square brackets define a list. Ellipses are grouping the arguments for a function. And curly brackets define a dictionary. So it's up to you. Yeah. Like if you want a list, then you use square brackets. If you want a dictionary, you use curly brackets. This is going to output a dictionary, by the way. So I'll show you. Hey guys. So it looks like everyone's kind of good now. Who's not good? Really?
No.
Okay. What's the error?
I think the top points, you need more P's, not less. I think.
Maybe this is... Oh no, careful. Yeah, perfect. You've got insert on. Can you just move that for a sec? So...
It's very hard to write.
Is it?
Yeah.
Oh, you're not used to our keyboards probably.
Yeah, maybe.
So you've got insert on, so... Oh no, you don't. Okay, so... Top points. Ooh, caps lock. Top flange. So you don't have top flange. See that?
Yeah.
It doesn't have a capital in it. So it's going to be really specific.
And also I have dyslexia, so this
Okay, yeah. So this doesn't help.
This will be very difficult for me. And also English and dyslexia.
Yeah, we'll get there. Undefined name trust division. What? Yeah, so maybe this was the wrong choice for you. That's fine. You don't have to. Okay, that's working now. Okay, good. Okay, guys, I need you to be hyper diligent with how you're typing stuff in. A lot of people are just typing in like top flange without the capital F, and then they're going and writing in the script top flange but with the capital F. So it's going to tell you, it's going to warn you, like when you have those types of variable changes, you're going to see warnings like this. I'll just put them up so you see it. It's going to go red, and it says name top flange is not defined. And what that means is you've probably typed it in wrong somewhere, okay? And you've got to go find it. So this is going to be hyper specific. If you don't get it right, it doesn't work. Now, as I said, if this is not the right thing for you, that's okay. I'm just starting you off with it because so that we can use it later. I want you to practice using Python going forward, but it's not required, okay? Okay? We'll get there. We're going to write this script. We're going to get through it. Okay, so this error is telling me that I haven't put in the right number of arguments. So this takes 3 arguments, and Grasshopper by default will just use a default value in K, and it doesn't care. But the Python version does. So in this case, the K input is a false, so we're just going to plug a false in here. And now it shouldn't be orange. Why are you orange? Defined curve, input 1 curve, error, data conversion failed from good to curve. Perfect. This is what I wanted earlier. Okay. Those of you who are using Rhino 7, this is probably working. Those of you who are using Rhino 8, this is not working. Who's using Rhino 8 right now? Okay, and it's probably giving the same error, right? What's happening is when you plug a component, when you plug anything into Python, Grasshopper is by default turning that into something that it can interpret. And in this case, it's getting the GUID of the object. So it's just the default thing that it does. If your script needs it to receive something other than GUID, such as ours, it needs to receive it as a curve, you can right-click that input, and what you want to do is change its type hint. And what that's doing is telling Python what type of object it is that is going to be receiving in that input. In this case, we want to set that to either a geometry base, but more specifically, a curve. And we'll do that for both. And we should be getting no error anymore. And when we print top points, it's going to be printing something pretty weird. Well, weird, like something you're not used to seeing. Are you okay? I can. You right-click. So right-click this and you set type hints. All it's doing, so you know how before I was going through and talking about the variables? Like, you know, a string is defined by quotes and an integer is defined just by typing a number. There are infinite number of object types that can exist in Python because we can define what they are. And Grasshopper has got these object types like curve and arc and line and surface and string. And so what we're doing is we're telling Python this variable, top flange, is a curve. So when it receives it, it doesn't convert it to a GUID. Instead, it receives it as a curve. And so you can run curve functions on it. Yes? It's still giving you an error? Okay. Oh, it's now not working for those of you using Rhino 7? What error is it giving you now? May I squeeze in here? Sorry. What? Sorry, if I have to reach over here. So you change that to curve. Jeez, why? Don't you just love it when things don't work? Oh, what? Let me just see if it's happening on someone else's. Yeah, hang on. Is yours doing the exact same thing?
I think it was working before,
What?
but I don't know what it was set. I think there was no type in.
Just type X. This is erroring up here. Thanks.
Right.
Yeah. Oh, there's no copy. Yeah, thanks. Copy?
Yeah.
Paste. Copy?
Yeah.
Paste. Yeah, paste. Oh no, you printed it. It's got it. So this doesn't comment that out.
Wait, I think it's fine before I set the type in.
Really?
Yeah, because I
Are
just
you using
added
Rhino 8 or Rhino 7?
8. I just added the false thing
Yeah.
after, because before you had like an error. Wait.
Warning, divide curve. Data conversion from failed to GUI to curve, right? Now it's running. Oh, it's this thing that's... What? What? That's really strange. Parameter count mismatch. I'm going to try and get mine to do it. Okay, for those of you this isn't working, just copy your scripts. Let's make a new Python component. Open that up. Paste it. Set your type hints. You'll also have to set the variable names again. Danny, have you ever seen this problem before? I've never seen this before. And if that doesn't work, oh. No, that worked. If that doesn't work, try it with this guy. So it's the snake, but it's a gray snake. It's just a different version of Python. So paste in that. Oops. It's definitely going to be something with Rhino 8 because Rhino 7 users are going to be okay. Just try it with this version, the grey one. If the grey, just tell me if the grey one works. Huh? The grey one worked? Cool. Okay, we'll just keep using the grey one then. Pardon? Yes. Yep. Okay. You okay, Sophie? Is your neighbour okay? It's working? How about you, Eric? How are you? Pardon? What's it saying? What's the warning? Yeah. So you right click those, and set type hints.
Oh, that's right. Okay.
To curve. Yeah, there you go. Yeah.
Even I'm getting one error, like it is failed to convert this.
Yeah. So right click top flange.
Okay. Oh yeah.
And type hint. Set that to curve. Cool. Yep. Is it because you haven't right-clicked this and done type hint curve? What's the error say? Divide curve. Have you done this? Have you put a false at the end? What error? There's no error. Yeah, so right-click top flange. Type hints. It's not curve. Yeah, so that's why we've run into this. This was what was happening to everyone else. So that's why we're using this guy.
Okay.
Cool?
Okay.
So don't forget to turn the type hint to curve as well. Okay. We're going to get through this. This was a really easy script to write with Grasshopper, right? Okay. So what these Grasshopper components return is not normally what a Python function returns, because a lot of these components have multiple outputs. So you can see here, we've got three outputs. What it does is it outputs them to a dictionary. So this output, so I'm printing top points. Top points is a dictionary that is made up of points, and then somewhere down here it'll say something like tangents there, and it's probably also got parameters, which is here. Okay, so it's a dictionary that has those variables in it as keys. So we don't care about the tangents or the parameters, we only care about the points. The way that you access items in a dictionary is by writing the dictionary with square brackets after it, just like you would with a function, but rather with square brackets, and then the name of the key that you want. So you remember how I said architect equals this? If I wanted to access architect in that dictionary, I would write dictionary square brackets architect. And so in this case, it's top points, square brackets, and then in quotes, points. And now I'm only printing those points. And you can see these are special things. They're Rhino geometry 3D points, but there are it gives us a preview of their coordinates. Okay? So let's just go back to our script. What did we do? We divided our top flange and we also divided our bottom flange. So let's do that. Should we just do this full vanilla like grasshopper components? Because dispatch, do you know what I mean? Should we just do dispatch? Yeah, otherwise I have to explain like 3 hours of for loops. Yeah. Okay. So we're going to do something to our top points, which is dispatch them, right? So let's just go have a look at dispatch. ghc.dispatch. This thing wants a list and a dispatch pattern, which is a pattern of booleans. So we'll do that. So top points, we're going to modify top points. We're going to replace top points by saying top points equals ghc dispatch top points. Now just remember, top points is a dictionary. So if we only want the points, we've got to put in this value top points with accessing those points. And then we need to put a dispatch pattern. Now Python is not going to like zeros and ones. If you're giving it booleans, it will want trues and falses. So we're going to write a pattern in here in a list which says false and true. I'm going to run this again. Now you guys are probably going to be running into errors left, right, and center right now. Because I replaced top points, this print had this trying to access the key points. It's probably erroring, so you should delete that, and then it probably won't error again. You can see now my dispatch top points is a dictionary that has a key list A and a key list B, right? So if you're trying to access a dictionary with a key and that key doesn't exist, you're going to end up with an error. So just be careful with that. But it's giving me a dictionary which is the equivalent of this output. So at this point. Yeah? Yeah. Pardon? False is the what? What's this one? Because we don't want to divide at the kinks. So if you've got a polycurve, So a curve made up of multiple curves. Where those curves join is called a kink. So if I have a poly curve, I can divide it. It'll divide evenly. And then if you say, I also want you to divide at the kinks, it'll include the kinks in that list. Pardon? It doesn't matter for straight lines. But the reason why I had to put false in there is because Python's going to throw us errors no matter what, because we didn't put the input. So we don't want it to do that.
I just wanted to know, when we run it, is there a reason behind you getting a list A first and me getting a list B first and then list A?
It doesn't matter. Yeah, dictionaries. Ironically, are not alphabetical. So they will return their values in any order. Yeah. I wish there was a way to clear this. Is that? Can I? That's okay. That works. Okay, guys. So we want to do the same. If it's working, we want to do the same thing. Copy that, and we'll do that to the bottom points as well. And if you'll notice, I've started to put these comments in here. Point A, point B, and they'll relate to these groups that I've put in Grasshopper. So there's point B, there's those divide curves. Point C is the dispatch. Yeah. Whoops. Keep this nice and organized. This is not typical Python, but I think it. Do you think it's appropriate for these guys, right? Yeah. No one here wants to use Python going forward, right? Huh? Like who wants to use this rather than actually using Grasshopper? Even like Johanna? You'd rather use Grasshopper, right? Yeah, okay. Which is fine. Okay, this is good. I've scared you away from Python, but Python's amazing, so please. You were scared by Grasshopper prior to this course, right? Okay, let's treat Grasshopper as a gateway drug to Python later, okay? It's not going to be useful for you until way down the line, but we will do some really fun things with it later this semester, okay? Some really fun things. But we're going to finish the script. We've just got to bite the bullet and get through it. Okay, next step is we want to weave. Whenever I say weave now, I get this Saturday Night Live skit in my head. You pulled my weave? You pulled my weave? Okay. So when we put in weave, like it's going to structure the data that goes into it exactly the same way as the weave component. So the first argument is the pattern, then the second argument is your stream of data, and the third argument is your stream for item 1. In this case, it's going to want a different list to true and false. So it's going to want 0 and 1. And then just remember, see here I've printed top points. Top points has a key value which is list A. So if we want it to access A, we've got to put in, so top points is getting A. So we're going to put top points list A. And then list B. Here's another criticism. I'll give you guys another criticism of Python. This, as you're working, unless you tell it to, is not previewing any of this stuff in Grasshopper, right? Like if I hide this stuff, I'm not Grasshopper, sorry, Rhino. Like if I hit play, I can't, like it's not showing me what I'm drawing. So there's another reason why I don't design with Python. Yes?
If in our code the list B is first, so does it still go to the bottom points or does it go to the top points?
Pardon?
If in our code, the terminal, we have list B as the first list.
Yes.
So does it still go to the bottom points or does it go to the top?
Oh, you're talking about this, when you look at this,
Yeah.
it says list B.
Yeah.
So dictionaries, as I said earlier, and I'll just say it again, dictionaries, ironically, are not alphabetical, okay? So the order that you build them, so if you put like architect first and then aardvark second, it won't return, it sometimes won't return that in the same order. They're not ordered, so it doesn't really matter where it is in the dictionary. The point is you're getting list A. So it doesn't matter where it is, you're getting list A. Yes? Pardon? No, I'm only printing it so that we can see it. Cool? And really the only reason I'm printing it is so I can see what these variable names are. Cool. So we're blind. We've got trust points. That should be our points. I'm going to print trust points. Just I want to see what that looks like. So I'm going to stop printing top points. So you can see because the Grasshopper component for Weave only has one output, it's not outputting the results in a dictionary. It's just outputting that list of whatever. So we don't need to access that as a dictionary. It's just a nice, clean list. So all we need now is our truss webs. They are going to be a ghc.polyline. And that is going to take a bunch of vertices. So we're going to throw into that the truss points. And then the second argument for polyline is whether or not you want it to close. In this case, we don't, so we'll throw a false into that. And we should be able to get the webs from that. Without even testing this, we're going to go to our actual Grasshopper component, right-click an output. So see how there's an output for A? We'll right-click A. Out is a special type of output, so just leave that one alone. Right-click A and paste into that this variable truss webs. And we should now have a Grasshopper Python component which, is giving us that curve, that polyline curve, which is that curve. It's wrong, but whatever. We'll get it right in a sec. But see how that's truss webs? That is this variable here, truss webs, which is making a polyline, which is what we want. So you got an error? Okay. I just want you guys to get to this point. Even if it's wrong. So what's your error? Yeah. Can you scroll up with that error? Help. Hang on. Go back up. Go back up. Help on function polyline in module.
Something here.
No. Lit B should be list. Try that. There you go.
Thank you.
What did I say about being careful with what you type?
Yeah.
Unexpected token top points. So GHC weave 01. Yeah, top points list A. Top points. Can you scroll up? There's one thing I've noticed is that your bottom points here has got a capital B. So get rid of that, change that. Try that. Okay. Still. Top points equals
It
divide.
was working till this point, and then when I did this, it just stopped working.
Okay. Can you print top points here? In between step 4 and 5? Yep. That's fine. I'll be able to read it. It still doesn't run. Can I?
Should I disconnect it?
Sure. Just come with here. You've got to create a variable in the Python that outputs. So see how I've done it here?
Yeah.
And then plug that into something like a curve. Okay, I'll help you out in a sec. Let's get this. Why is this erroring? Line 42, but it should still print top points. Okay. You need a comma to separate that argument with this argument.
Oh my god.
There you go.
Thank you so much.
Yeah, it's really fickle. It's going to be really fickle.
Yeah, so you've got to
Okay, it is giving you an error. So polyline, this is not polyline. This is polyline collapse. Okay, now it's giving us an error, a new error.
This panel is null. Is that part of
That's
it?
no, that's not. That's the output. Module object has no attribute polyline. What have you done? GHC. Yeah. Let's just try this again. Trust web equals. Okay, cool. Trust webs equals GHC dot polyline. It's because you didn't have a capital L. That's fine. That's fine. And then we want trust points. Oh, okay. And then false. Ta-da!
Okay, cool.
Right, so that's a curve.
Yeah.
Now, I reckon the reason why it doesn't look like we've drawn anything here is because we've plugged the same curve into both these inputs. Oh no, that's... yeah, so you're dividing the top flange. So you want the bottom flange up here.
Okay.
Bottom. Okay, that didn't do much. Yeah, 1, 2. Top flange, bottom flange, top points, bottom points, top points, bottom points. Yeah, that should be right. Run that. We're still getting... What? Why? It's so weird.
You get rid of this Python 3.
Yeah, just delete that. But it's not going to affect it. Divide curve, one flange, trust division. Everything looks like it's correct. Maybe comma. Okay, now you're getting that.
Oh wow.
Yeah. Okay, it's wrong, but you've got
But
it.
it exists.
Yeah.
Excellent.
Cool.
Thank you. Sorry.
Polyline needs a capital L. Polyline needs a capital L.
Oh.
That didn't do it. That's it.
No. When you switch the list around.
Yeah, it does. Yeah, that's.
But like, that
we'll
doesn't
get
make
that.
any sense. Because wouldn't it intuitively just be like mirrored if it was the other way?
Yeah, but it's not right now. That's not working in a way because look, it's going from the top to the bottom rather than the bottom to the top. Like we want it to start there, not there.
Oh, okay.
But you're right. All we have to do is change the pattern.
Okay.
It's this pattern that you want to change. Change that to a 1 and a 0.
Oh.
Oh. What did you break? Oh, you've got two brackets there. Cool. Oh no. That was right. That's correct.
Oh, right. Wait.
We'll work it out.
Oh, but then that wouldn't work then if you changed it.
Yeah.
But then why does it make it slanted?
That's correct. That's what you wanted, right?
Yeah.
Yeah. Cool.
How come mine's not starting from the bottom?
You've got to you changed your you got to change these as well.
So you change it to B and A.
Yep. Yep. Press play.
That means.
Oh no, sorry.
okay,
Change that.
Wait, so
No,
wait.
now you have to change it back to.
Yeah. Yeah. So how come yours is A and B?
That means just selecting random like points from the list.
No, we're the same, yeah.
It's making the list like random.
So yeah.
No,
like
it's not making it random.
Oh, okay, never mind.
1, 0.
It's doing what you're telling it to do. Your scripts are now the same.
Yeah.
Yeah.
But I don't know why does it make it slanted if I switch them around?
Okay, so what do you want to just do something? Switch something, and we'll have a look.
Like if I did like list, like made this list B
Yeah.
and that A.
Okay.
Because then wouldn't it just?
So what it's doing is it's taking points from list B, and list B is the alternate point. So it's not that point; it's that point there, right?
Yeah.
And then it's taking points from list A, which is this point. So this is the starting point because we're putting that into. This is the.
Wait, so what is 1 and 0? What does it do to the list?
That's like this.
Yeah. So then,
Yeah, that looks a bit weird.
by putting 1, does it mean that you're taking the second one or list B?
Yeah.
Yeah.
It's not the second. It's not that it's taking the second one. What it's doing is this should be taken from here, which
So 1 should be taken from A.
which is bottom A, which is true. List A is that list there because it's 0101, right?
Right.
Because we see the pattern up here is false true. So yeah, it's taking from that one, and then it's taking from list B, and list B is there, right?
Which is true, false, true.
Yeah. So we're about to do that now. We just need to. The problem is like I give one line of code and people are like, it's broken because they've typed the wrong thing in. Yeah. Yeah. It's going to be hard for me to get in there. What? Can I get in? Thanks.
I have one doubt and 3 questions.
Yeah.
So first thing is, so basically you're saving this, whatever the result of this into this CP1.
Exactly.
Why is the same variable used in dispatch?
Because what we're doing is we're just replacing it.
Okay, you're replacing.
You can use a different variable if you want.
Okay, so so when you're using weave, so for instance, when you're dispatching, in this case it's points.
Yeah.
So if it was a curve, you just type curve.
No, so because there are multiple outputs from these components.
Yeah.
What Grasshopper Python is doing is it's providing all of them in one variable,
Okay.
which is a dictionary.
So if I just change from points to A1, it will still work.
No. No. So look here. This is the output of CP1. Right? It's a dictionary that has tangents, points, and there's parameters, and points will be somewhere in there. There's points, right? Which is this: points, tangents, and parameters, right? So because it's one function, but it's returning multiple types of objects, it has to return them in a dictionary.
So in this case, if I want like tangents, I just type tangents here.
Yeah, but you can only type into that what it's returning, which is either points, tangents, or parameters.
Okay.
If you've got a component like weave, which is here, not weave, sorry, dispatch. Dispatch is going to return 2 parameters, list A and list B.
Okay.
So that's why we're using list A here, and so on and so forth.
Okay. And one more question is, so here in dispatch, we used, so this is true and this is false, and this is true and this is false.
Yeah.
And we are using the alternate ones here. Why are we using false?
That's what we're going to sort that out right now.
Okay.
Cool. Whoop, 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 whoop. Thank you. Sorry. All good? All good? All good? All good? What's up?
All the things you've done just recently.
Yeah.
Does that doesn't work on 7, does it?
Yeah, it does.
It does?
Yeah.
So I don't need the Python 3 and Python 2.
No, there is a Python component in Rhino 7. It's just Python 2. But it's called Python.
That's it.
Rather than Python 2.
Ah.
Okay? So there are some... Who's using Rhino 7 right now? So he's using Rhino 7, he's still doing it. Cool?
Yep.
Working?
Yeah, it's working.
Working?
But, this curve is red.
Oh. Why?
It does look like...
Why is it red?
But
Oh, because you plugged it out of out.
I'm supposed to plug it. Okay. What's
Working?
the difference?
Out is the terminal. So see this terminal here? When you print, print will also come out. Yeah.
Okay.
Cool. You can get rid of out. I'll show you. I'll show you how to get rid of out. I'll show everyone. Working?
Yeah.
Working?
How can I display what I've done so far on?
Why? So you... Okay, so not working. See truss webs? That should be... Okay, you didn't press play. Okay? So there it is.
Oh, that's it?
That's it. See? See that curve that I'm selecting? That's that green curve there in Rhino. Cool. Good job. Okay, so I've got a crappy looking truss. It's not a very good truss, right? It's probably because my variables I've put in. So what I'm going to do is just quickly this and set this to 0 and 1 rather than 1 and 0, and it's giving me the correct truss. Cool? Okay. We don't have to touch Python for ages, okay? But that is just a little introduction to it. But you can see how it functions similarly to Grasshopper. The really interesting thing here is there aren't cables that go from component to component. Instead, you are referencing those via the variable names, okay? I've learnt about various students' dyslexia now, like, and the different levels of dyslexia and just not being able to type properly on a keyboard. So Grasshopper at least throws that out, right? So it's choose your demon, right? Do you want to type it or do you want to draw wires? It's up to you, okay? But any Grasshopper script that we write going forward can be written this way. I don't expect anyone to do it, but if you want to, go for it. Python, this is literally scratching the surface of Python, okay? There's way more things that we can do with it, and so please do not discount it because of what we've just done, because it seems like no one wants to use it ever again. Cool? Okay, you will get better at typing using Python. There's someone at my work who really needs to learn how to use Python, and I think the reason why he doesn't learn it is because he can't type. So, like when he types to me, it's like as if he's got fat fingers. He's gonna hate me talking about. I'm not gonna say his name. Cool. I'm not bothering putting those lines in. Okay, so it is 12 o'clock. We've still got 2 hours. So we've done dispatch, we've done weave, we've done things like list item and whatnot. Okay. what can we do with these next 2 hours? I can either teach more Grasshopper or we can talk about your assignments. It's up to you. Assignments? Okay. I'm going to stop recording then. Do you guys want to, those of you who need to eat, you go for it and start eating? Or what we could do is, shall we move upstairs and talk about your assignments upstairs in a studio environment? Here, really? It's really hard for me to talk to these people. You want to do that? It's up to you guys. What do you want to do? It's democracy. Stay here? Okay. Because you want to keep working on your Grasshopper scripts while you wait, no? Huh? You just don't want to go upstairs? Okay.
Would we have to plug everything in upstairs and all that?
It's up to you. Yeah, we can stay here if you want. Cool. So, how do we do this?